Hello, this is the implementation for the Simacogo game for the class of CSC 480 Artificial Intelligence. I'm going to start by explaining the board class. The board class itself is the creation of the board, which is 9 by 9, and I also used a toString method to append the dots to create the grid and also the spaces. This class also contains other methods such as the Boolean methods, such as the movement of the player, if the player is moving or not, and then if the game is over or still running, and also contains a deep copy of the board that helps in creating duplicate board instances. Also, the board class is used in helping determine the score of the game, of the user and the AI at the same time, as well as also calculate the board score at that particular instance. The main purpose of the board class of all is finding the score. Determining the score is in four methods. One is directly up, towards the right, towards the direct right, and the diagonal right, towards the direct right, and also diagonally downwards. Each of them have a separate if loops and conditions so that the user is tracked towards each direction and the AI counterclockwise the action. After this, we can proceed to go to the Go game itself. This is the game and its main function. To start with it, I have a couple of instances of the functions of each of the class initiated over here, so that each of the class's instance can be called up. So the AI class can be determined by the hyphen symbol, and the user class can be differentiated with the help of a plus. There's also the instance of a player that manages both these instances, and a movement monitor that contains the column number and the score of the user or the AI. Heading back to the game, this is where we get to choose if the alpha beta pruning is on or not. We also get to choose the amount of depth that we want to choose. Once these two factors are set, then the game starts. When the move is made, which is a Boolean function, that's always true, so that the loop continues as the game is begun, and the game does not end if the user inputs a wrong value. When the user inputs his value, it forwards the scanner method to the predict a user move, which is a method over here. So the predict a user move records the answer from the user, where he is supposed to choose a column from 1 to 9. Once that is done, there's a break statement that checks the condition if the column chosen is correct or not, and then there's the minor check if the game is over or if the game is still running, and then the game denotes that it's the AI's turn. Once the AI reaches its turn, we forward the function to the AI predict AI move. So the predict AI move is a class which is recursive function for the min-max algorithm call, and once we will get into that shortly. Before I do, I'm going to continue the rest of the game. So once there is a recursive call done to the game and the values are given back as a player movement, and the AI is chosen as a particular character, the min-max is called on to act upon. And once the entire algorithm and the AI plays together in a proper way, the scores are marked down as the AI score and the user score, and is then displayed on the console. The comparison between the user score and the AI score is done within the algorithm itself, and if the user it's done over here. If the user score is greater, the user wins. If it's not, the AI wins. Here we move on to the pruning and the min-max algorithm class. So it has five values: which player is playing, the board on which it's supposed to be the algorithm works on, the depth, the alpha beta, and the column number. So once we enter into this, the depth is taken and considered, and if the game is not over, so it then considers the board and the board score in that point. Once that is done, an instance of the AI class is taken, because the AI has to decide to make a move, and then there are duplicate copies of the board done, and there's a recursive call for choosing either the max or the min. And here, if the alpha beta pruning is on, the maximum move is compared with the alpha in the maximum, and if it is greater, alpha is set to the maximum score. And also to check if we actually need to do pruning, the beta is compared with the alpha if it's less or equal to, and if it is, then the beta is returned. Same, the opposite goes for the minimum, and the beta is chosen and the depth is -1 here, so that is because it's minimum. And then the final move is compared with the minimum move, and if it's lesser, the minimum move takes the final move score. And then the beta is compared with the minimum. If it's greater, then the beta takes it, and the minimum move is done. Thank you for watching the video. This is the implementation of the Simacogo game.